So what is an indicator of a moderating effect? And this is, I think, similar to what Michael was expressing earlier. Um, when you ask the question, what is the effect of X, some independent variable, on some dependent variable, when the answer is, well, it depends on some third variable, that is an indicator that you have a moderating relationship that is of interest. The majority of this lecture is dealing with how do we assess moderating effects in a regression context. So we'll be talking about regression again. We already know how to do this in ANOVA, right? So we've spent the last several weeks, and you'll potentially be analyzing significant interactions or moderating effects with your assignment 6 that is due this week. So the majority of this is focused on regression, but at some point I make it pretty clear about when we should use regression and when we should use ANOVA, and I think we've had some of those conversations. But we'll bring up ANOVA some as well. The Cohen definition that I have, I think, also that I have there expresses pretty clearly what we talked about earlier in terms of defining what a moderating variable is. And I don't know, you can debate with Cohen's quotation regarding is testing interactions at the very heart of theory testing or not. I think that's a debatable point. But what isn't debatable is that they really are everywhere, and they clearly play an important role in our understanding of social sciences and theory. Whether they are at the very heart, I'll let others make that judgment. Although I think many would concur with that conclusion. So the nomenclature that we typically use is that Z is the moderator variable, X on the horizontal axis of a two-dimensional plane. X is generally used to denote the independent variable, and Y on the vertical axis of a two-dimensional plane is the dependent variable. So we have Z, X, and Y, and when Z moderates the relationship between X and Y, the bivariate correlation between X and Y is generally small. Why is that? Why is that true?
If the correlation is very strong, then they are the same. The variables are the same. We just use different terms. For example, if they are larger than 0.9.
Yeah, I think Shigofai, that's true, but I'm not sure that that would be the answer that I would give here. I don't know that it has to do with being strong.
If you have a high correlation, you don't need a moderating effect?
Why don't you need one?
Because you already have a clear relationship.
Yeah, I think, and that's, I think, along the lines. Is that what you were also suggesting, Chico? Yeah, and so the thinking, and the word generally maybe should be underlined there because this is not always the case, but generally I think it's the case. If the relationship between X and Y is moderated by Z, when Z is one value, X is going to be, the relationship between X and Y might be small, and if we change the value of Z to another value, the relationship between X and Y is going to change. That's by definition what a moderating variable is. And so The reason why it's generally small is because we're taking what might be a large correlation for one level of z, and what's a small correlation if we look at the same correlation for another level of z. And if we put those both together, we get something that's generally small. But if we disaggregate that, which is what we're doing, if we disconnect that and look at the various levels of z, we can see where the relationship changes. And that is by definition what a moderating variable is that the relationship between x and y is not consistent across levels of z, the third variable. So if we change, and by not consistent, it's not, it's significantly different. Not just by chance they're not going to be exactly the same, but it's significantly different across levels of some third variable z. In terms of the math, it makes no difference in terms what your z variable is and what your x variable is, because the final result will, as you'll see, will be equal, but theoretically, the distinction likely makes a big difference. So mathematically, it makes no difference what's z and what's x. So those variables could be interchanged. We could do the analysis, and the results would be the same. Either way. So the theory has to drive what's the moderating variable? What's the thing that as this value of this variable changes, it's going to change the correlation or the relationship between two other variables. That's what the researcher has to determine. And hopefully previous research, theory, intuition, instinct, all of those things will help you come to that conclusion. The moderator can be a nominal variable, or the moderator could be a metric variable. So if we have a nominal moderating variable, generally, well, if both x and z are nominal, what statistic would you use? What procedure would you use? What's that? No, so y is continuous, is a continuous dependent variable, and we have two nominal independent variables, z and x. What statistical procedure would, what's that? You could, but what else could we do? ANOVA, right? That's exactly what we do. That would be my first instinct. Very good. So if we have two nominal independent variables, you could dummy code them and do multiple regression, but why would you want to put yourself through that heartache? Just do the ANOVA and be done with it, right? And the result at the end of the day, exactly the same, and you save yourself a couple hours of labor, okay? What happens if we have one nominal independent, let's say z is nominal and x is continuous. Would you do ANOVA? Shake your head no, why not? Yeah, it's not a grouping variable. Could we just make it a group variable? You could, right? Let's say we had age. This is an example we used last week, right? We had age. Can we just put people into two groups? Young and old? We have age from 18 to 100.
Yeah.
Can we just divide people? Does it make sense?
You could.
Does it make, you could. Does it make, yeah, you could, yes, mathematically, easy to do. Would it make sense? Theoretically, who knows about age, but in most variables that age isn't very interesting. But in a variable that you measure that's on a continuous scale, usually the rule would be don't throw away information. And we're throwing away a whole bunch of information. We're saying everybody between 18 and 50, no difference. Everybody between 51 and whatever the max age is, no difference. And we all know that it's sort of would be an odd way to handle the data. But if you did that, you could do that. And so what I would do if I had one nominal independent variable and one continuous independent variable, the best course of action would be to use regression to test for moderating relationships. And then you have to dummy code the one nominal variable. Easy enough to do, and you wouldn't have to throw away any data or any information about your participants. And then clearly, if you have two metric or continuous variables, the best course of action would be to use regression to test for the moderating relationship. You could somehow group those two continuous variables and then just do ANOVA, but it just doesn't make any sense. And I think this is the cynical me, which I don't know if there's another me, but I hope there's not. The cynical me is the reason why people do that is because they don't know how to test moderating relationships with regression. It's not normal textbook sort of. If you do a couple of graduate level statistics classes, it's usually not a topic that comes up. It should be a topic that comes up, and so I think that's why, because they don't know how to do it any other way. Well, let's just make them into nominal or just grouping variables. We can do ANOVA, and I think that will work. And that is the cynic in me. Same, we can do three-way interactions, four-way interactions, but they get increasingly complicated. And I just would never do, no reason to do anything greater than a three-way interaction. If somebody thinks they need to test a four-way interaction, I would find a way around it. I personally wouldn't do it. Almost impossible to make sense. Not impossible, but very, very difficult to make sense of. And maybe after you spend some time studying it, you could understand it, but good luck in convincing a reader in a couple paragraphs in a journal article what that means and how to understand that. And reviewers, more importantly, because they're the ones that are going to make judgments about it. So that's the point I'm making. So graphically, so we think of arrows as meaning this arrow here, the horizontal arrow, meaning X has an effect on Y, right? That's sort of how the interpretation of that arrow. And this arrow here just means our moderating variable, remember Z is for moderating variable, our moderating variable has an effect on the relationship between X and Y. So this to me is the graphically a meaningful way to understand moderating effects. It's just that the moderating variable changes the relationship. When we change the levels of Z, it changes the relationship between X and Y. Another way that moderating relationships are oftentimes depicted, although I think less intuitive, is just X, Y, and then the multiplicative quantity X and Z, and then the multiplicative quantity X times Z, which is exactly what we do when we test moderating effects. We take whatever your X variable is, whatever your Z variable is, we multiply those two together in SPSS, and then that becomes that's the moderating effect. And if that X and Z variable significantly predicts Y with X and Z also in the equation, so we have three variables, we have X, we have Z, and we have X times Z. If this is a significant predictor of Y with X and Z in the equation or in the model, then we would say that Z moderates the relationship between X and Y. Does it make sense? The preference for me would be this one, just intuitively it makes more sense, but mathematically this is what we're doing. So this shouldn't be anything new. If we're using regression, we're not going to use a nominal independent variable unless it's dichotomous, right? that should hopefully that should, I don't know about second nature, but it should be whatever comes before second nature. Is it first nature or whatever that would be? That it should be if it's a nominal, if it's a grouping variable, it just can't be an independent variable in regression unless you democode it. Okay. And this is the conversation that we've already had regarding ANOVA, and if we have two nominal variables, just do ANOVA. That it just makes exactly the same results, and again, save yourself a little bit of work. So these are the steps that one would go through in order to test whether Z moderates the relationship between X and Y. And again, graphically, this is exactly what we're going to do. We're going to just multiply X times Z together and include all of these in an analysis. And if X and Z is a significant predictor of Y, then we say that we say exactly that it's a significant, that there's a moderating relationship there. And the way that we do that is, remember hierarchical regression? We talked briefly about we put variables in different blocks when we do analysis. So we can have some variables in block 1, and then we can click and get a second block of variables that we can add, and then a third block, and you can add, I don't know how many blocks, but you could add a fair number. In this case, we only probably need 2 or maybe 3 at the very most. And so Y is regressed on the independent variables hierarchically, meaning in blocks, meaning that we use this process called hierarchical multiple regression. Not to be confused with hierarchical linear modeling, which is a different procedure, both having the word hierarchical as the first descriptor. But one's hierarchical linear modeling is much different than hierarchical multiple regression. So specifically what we do is the two independent variables, X and Z, are in block 1. And then in the second block, we put in the multiplicative quantity, X times Z. So again, you just use, how would you multiply two variables in SPSS? What's that? And what function would you use? You use the asterisk, and you'd use, how would you do that in SPSS? Is it compute? Yeah. So just do a compute statement, and then use the star thing in between the two, and you'll have the multiplicative quantity of those two variables. We have to. There's just a quick. There's another step that we add in there, but that is basically what we do. If you have some covariates that you want to include in the analysis, you can add those into the first block, put X and Z into the second block, and then put the XZ multiplied quantity into the third block. So we can add covariates or additional independent variables, but just put those in the very first block. Second block, put the X and Z, and the third block, put the X times Z. And then what we're looking for is the R-squared change in the block that has the interaction variable. And if the R-squared change is significantly greater than 0, so in other words, the R-square, the XY significantly predicts Y, or the XZ significantly predicts Y after controlling for the X and Z individually, then we know that there's a moderating relationship taking place. To minimize problems with multicollinearity, what's multicollinearity again? What's that, Jackie? Close. More specifically, what I would. Yeah. So if you have independent variables that are correlated with one another, We call that multicollinarity. Some people just agree collinarity. So to minimize problems with multicollinarity and to actually make the interpretation easier. And we're going to talk about how to graph out the interaction and to make graphing a lot easier. It makes sense to do what we call center the independent variables prior to the analysis. And I would also center the covariates. It just takes a quick step to do that. And centering is simply means we subtract the mean of the variable from each case for that variable. So it's somebody's score on a particular independent variable minus the mean for that independent variable for the whole group. And that when we do that across, we do that for all of our data, the new mean for the centered variable will be 0. If you think about that for a few minutes, it'll make sense, because if somebody's score is exactly the mean, and their score minus the mean is going to give you 0, and negative scores are going to be below the mean, positive scores are going to be above the mean. It's similar to standardizing the scores, although we're not dividing by the standard deviation. All we're doing is getting a mean of 0, which does minimize some of the problems with the multicollinarity. And then we use the centered variables to create the interaction term. So we center the x variable, we center the z variable, and then we take the two centered variables and multiply those together to get the interaction term. And then we use these newly created variables in the multiple regression. Easy enough?
So when we get the interaction, we get the mediation.
We're only testing moderation, right? Did you mean moderation?
Yeah, but you said that in the mediation interaction using the two.
Yeah, so I did say that tonight. Some independent variables, sometimes we have to think carefully about, should I be testing a mediating variable or should I be testing moderating variables? But if you decide to test for a moderating variable, you are not testing for a mediating variable. Completely different tests that you have to do if you thought testing for the mediation was the most appropriate test, theoretically, or just based on your experience or intuition or whatever. Does that make sense?
Yeah, so this is the interaction of the moderation.
Interaction and moderation mean the same thing. That would be like saying it's the moderation of moderation, right? Saying interaction of moderation, and it's redundant, right? I wouldn't phrase it that way. So for some reason, I'm just not quite sure if I'm getting.
Probably
So two very distinct things: mediation and moderation. Sometimes we have to think carefully about which test to do. And when we talk about mediation, I think that might help to clarify how we test those differences and help you clarify what thinking should you be, how should you think about these problems in terms of which procedure should you use. Okay, other questions? So far, so good? So here's the motivating example. Does the level of education moderate? So education is the z variable. Does level of education moderate the relationship between TV news viewing and campaign knowledge? So the X variable is TV news viewing. And the dependent variable is how much knowledge they have about a particular campaign, while controlling for a bunch of or several other theoretically relevant variables. So does that make sense to test? Well, somebody try to articulate, how would we explain this to your mother? We want to tell mom about moderating relationships. How would we, and this particular one, how would we, this is what you did your dissertation on, and she wants to know what you've been doing for the last couple of years, and how would we explain this to somebody who's not familiar with? Anybody want to take a shot at it? Nobody?
No.
Yeah. Thank you.
Okay, Mom. The level of okay, the level of education of the U.S. population now.
Yeah.
Campaign knowledge. So wait, can I give me like a soundbite
Yeah.
for campaign knowledge? Like,
How much people know about candidates?
yeah. So how much people know about candidates is affected by, and their relationship with TV news viewing is affected by the level of education which they've attained. So, for example, if you have attained a higher level of education, such as a college bachelor's degree, the relationship between TV news viewing and campaign knowledge would be increased, right?
Could be, but you've spot on in terms of explaining it to mom. The part that you're actually wrong is but not because you're hypothesizing, right? And you just, and I just know the data. It ends up being where people with high levels of education, and we'll see this, people with high levels of education or higher levels of education tend to learn less as they watch more TV news. People with lower levels of education tend to learn more as they watch. So it has something to do with processing and resources that people. So spot on in terms of the explanation, the hypothesize. Yeah. But I think I would have said the same thing because it is a bit counterintuitive. You think the more you watch TV news, you should learn more, right? But those of us who study TV news, we know that TV news isn't the best source of information. Oftentimes focused on the horse race of who's up and who's down and some gaffe that somebody made in a speech and all of the hoopla, not the nuts and bolts of why people vote for. So that's
It might be because you're more skeptical and cynical.
the more educated people. That would be another hypothesis that we could test, and I think they probably would be if we sort of look, certainly more skeptical and think critically more about media than people with lower levels of education. So very good. That's exactly what we're testing. Makes sense. So good. The first step is we examine the data for the usual assumptions. So I looked for outliers. I looked at the normality of the data. I looked at the missingness of the data. Looked for multivariate outliers. Did all of that stuff that we talked about the first 2 or 3 weeks of the semester. That would be the first step. Once we get through past that, we have to center all of the variables except for the dependent variable. And it doesn't make any sense to center dichotomous variables because you just still end up with 2. Instead of 1 and 0, you end up with something like 0.55 and 0.02 or something. And so it's still a dichotomy. So you just center all of the variables except for the dependent variables and anything that's dichotomous. Right? And what's centering again?
Subtracting the mean from the score.
Yeah. And you do that. How can you do that in SPSS?
Compute.
Do another compute statement and just do a minus. You can do calculate the mean maybe separately if you wanted to, and you can just do a variable minus, and we can do this analysis so you can see a variable minus the mean and put in the mean quantity, and then compute that for all participants. Or I think within the compute statement you can actually have it calculate the mean, and then you don't have to calculate it separately. So we're going to center the variables, and I ran the analysis in 3 blocks. In the first block, I put in all my covariates, and the covariates that I used was a C for centered, how interested they were in politics. Female, I didn't center it because it's dichotomous. Non-white, I didn't center, so just coded 1 for non-white, 0 for white. Dichotomy, no need to center. Centered for age. Strength of political party identity. So not whether you're Democrat, Republican, or Independent, but how strongly you align with the ideology of those 2 parties as it's articulated in the media or wherever you get it from. How much they talk about politics. So that's discussion centered. How much they read the newspaper. And this is the general political knowledge question again. So those were the covariates that I used. I put those in the first block. And this is a table. We looked at the table like this towards the end of the regression work that we did. Might have even been that last day before we went and started talking about how to do principal components analysis. And so in this case, we can see that our control variables explain a fair amount, 0.225% of the variability of our dependent variable campaign knowledge. Small, medium, large. 0.225. Large, yeah, that would be a large effect for sure. And then in the second block, I added to the second block the education and television, again, both centered as well. And the R-squared change, it added 1.4, those 2 variables explained 1.4% of the variability of our dependent variable. So this is the total R-squared, and this is the change. So if we take 0.239 minus 0.225, it's going to give us 0.014. And then in the final block, I added the interaction term, which is just TV, and then you could put whatever, but I just put by to indicate that I multiplied it. TV by. I don't think SPSS or most software doesn't like you to use an asterisk in it, so I just use, that's how I just always abbreviate it. So TV by. Education is just the multiplicative quantity of these 2 centered variables. I didn't put the C there. I didn't feel the need to. But they are, it's the multiplicative quantity of those 2 centered variables. And that's also significant. Right, and we know that because the R-squared change, bless you, the R-squared change was greater than we expect to get by chance. It was small, but it was significant. Again, our N is fairly large here, so we have a 130 or so participants, or actually more than that, probably closer to 140 participants, or 1,040 participants. So our N is fairly large, so we have quite a bit of power. And so this change isn't large. Actually, it's quite small, but it's greater than we'd expect to get by chance. And we'll see that once we graph this out, we'll see that that there is this sort of strange thing going on where people who have lower levels of education, as they consume more TV news, learn more, and as education increases, that line actually they tend to learn less and know less about politics as they consume more TV news. So when we do this analysis, and I didn't show you this yet, but it's on coming up slide. When we do this analysis, we have a regression equation that we get. And remember, the regression equation is made up of B's and betas. How do we interpret B again?
Slope.
What's that?
It's the change in the 1 unit change in the independent variable causes X amount of change in the dependent variable.
Yeah, and I would use the word cause and quote is leads to or predicts. You ruffle some people's feathers if you said cause, especially if we're using just correlational data. But exactly right that it is the predicted change for 1 unit change in the independent variable. That's what B is. And then beta is just a standardized version of that. Generally ranges from -1 to +1, but betas can fall outside that range. Again, usually a sign that something that there's problems with multicollinearity with your analysis if you have betas that are outside of the range of -1 to 1. But just looking at the B's or the betas alone, impossible to understand the nature of the interaction. So just by looking at those B's and betas, we would know that for people who have low levels of education or lower levels of education, that as they watch more TV, they tend to learn more, and that people who have higher levels of education, the slope of that line is negative. We wouldn't. There's no way of knowing that by just looking at the output for the regression. We're gonna do just some very 8th grade math. And that will allow us to compute the values for a graph, and then we can just graph these in SPSS or in some other software. There are, I don't know if this used to be an Excel program that you could buy, or maybe it's free, I forget, that at least said that it would do all of this calculation for you. I never had any success with it, but there are some tools out there that will help you. I think you'll see that it's pretty straightforward process, and instead of buying a tool or even using somebody else's tool, you'd probably just be better off just doing the analysis yourself. So I say that, and you can agree or disagree with me after we look at a couple of these next couple slides. So this is the output for the final block 3 of our analysis. And if we were so inclined, we could look to see which of our covariates were significant predictors of knowledge. And we can understand that. But what we really want to do is understand, we care about understanding the nature of this interaction. And again, we can see that the interaction is significant. And this wouldn't be the place you'd look. You'd actually look at the R-squared change. But if the R-squared change is significant, this is also going to be significant. So in some ways, it doesn't matter all that much. And remember from way back when, we talked about calculating predicted Y. And we could line up all of those variables and use these B's and come up with this prediction equation. So Y predicted is equal to the intercept plus 0.141 times, what do we put in here? C, SPID, that's strength of party identification. Where do we get a value for that at?
It's the observed
Yeah, for one of the observations, right? So take one of your participants, find out what their value is for strength of party identification, centered, minus 0.023 times whether they're male or female, plus this, minus this, right? So it's, you had to do a couple of these for one of the homework assignments where I had you predict 4 or 5, maybe 5 values. And so that should be familiar. And we know that the centered variables have a mean of 0. And if you think about what we did when we centered the variables and what I said a little bit ago, they have a mean of 0. We could reduce this down to that, given, we could reduce this down to this, given that knowledge that we have about our covariates. And if we want to hold the covariate at the mean value, right? And so the mean is equal to 0. So 0.141 times 0 is equal to, comes out, right? Same here, same here, same here, same here. So we can set those all to 0, or the mean value, and all of the covariates come out, and we end up with this equation. Now, if we didn't center those variables, you can't do that. You could, well, center the variables. There'd be ways to get around it. But the easiest way to do it for sure is just center the variables, and then this value times 0 is always going to be 0. And you can just drop those out of the analysis because they don't, again, if we want to hold this at the mean value, we want to control for it. And that's what we mean when we say control, is we just want to hold it at the mean value. We put in the mean value, it's going to be 0. So it is utterly useless here because it doesn't help us understand the predicted value at all, because it's always going to contribute an amount of 0. So we end up with this equation where we have the intercept, and then we have the slope for television. Remember, these are, or B for television. Another word for that would be the slope. We have the slope for education, and then we have the slope for the interaction term. So far, so good? I could just get rid of these names to simplify things. Instead of talking about TV and education and the interaction, we could talk about just standard terms or use the same terms that we had earlier. That, I think, simplifies this a little bit. So I can take out those names and I can just put in x, z, and x times z, right? Easy enough. And because we talked about earlier that x is the independent variable, z is the moderator, and then this would be just a multiplicative quantity. And this equation that we have takes this general form, right, where we have the predicted y is how we read that, so y hat is referenced as predicted y. B 0 is thought to be, or is the intercept term, and this would be the b associated with the x. This would be the b that's associated with the z, and the b that's associated with the x times the z. And so our equation here takes that same form, right, where we have an intercept plus 3 other terms with an x, z, and an x times z. And we can just rearrange this and do maybe 6th grade. Did we learn that? How did we just factored out this as x? So we just rearrange and move the this term over here and this term over here, and we have those two, these two, B0, the intercept, and B2, the moderating effect, plus this quantity where we factored the x out, right? Nothing complicated there at all yet, right? And we refer to this as the simple intercept, and this second parenthetical value as the simple slope. So we're going to use this to come up with the intercept value, and we'll use this to come up with the slope value, and then we'll plug in some additional values, and we'll be able to come up with a couple points on a plot. Do that for several levels of the moderating variable, and we'll be able to then plot out our variables of interest. So in our case, we can simply do the same thing with our equation. And if we come up with some value of z, so come up with a value for z based on your data, and insert a value for z here, insert a value for z here, and really what we have is the y predicted value is going to be equal to an intercept plus some slope times the x value. Right, all we're going to do is we're going to come up with a value for z. I'll tell you what value makes sense to use. We just take this plus that multiplicative quantity, and then here we just put in the same value for z and do that math, and we come up with something that that looks exactly like this, where the b0 is the intercept and the b1 is the slope. And then all we have to do is pick, using this equation, pick two values for x. And then on a two-dimensional plane, if we can calculate two values, we can draw a line between those two values, and we can easily then plot the interaction. So the first question is what value should we use for z? And the most common values that get used for z would be use the mean value of z, and then plus and minus 1 standard deviation for z. That's the very common. You might have other reasons, and I have other reasons here. But if you don't have any other, and this makes sense to me, but in most cases, this is what I would do. So we'd set z to the mean, and then plus 1 standard deviation, and then minus 1 standard deviation would allow us to come up with and plot three different lines for low, minus 1 standard deviation, medium, the mean, and high, plus 1 standard deviation. In our case, it seemed to make more sense, it was more intuitive anyway, to examine z at where the person has a high school degree only, and where they have a BA degree or BS degree, some kind of 4-year degree, and then advanced degree. You could set it at different values if you wanted to, but this is what made the most sense to me. So with a little bit of math, we can come up with something that looks like this. And this really wouldn't take, if you sort of follow it step by step, it wouldn't take you all that long, and a calculator is all you would need. So in our data, remember I centered z, so negative numbers means less than the mean. So our z for somebody who only has a high school degree is minus 1.1. This is the same equation that we looked at earlier. I just plug minus 1.1 into that, and in these two, and there, just carry out that math, and eventually I come up with an intercept of 3.246 and a slope of 0.006. And that slope is, and you can interpret that slope as education, as news consumption, TV news consumption increases, levels of knowledge increase. That would be the interpretation. In this case, it's specifically for people who have high school level degree. We can do the same thing for BA level degree or 4-year degree. And we can see that the slope of that line is negative. If you carry out that math, the slope is negative. So as they consume, meaning people with 4-year degree, as they consume more television news, would we say they actually get dumber? But there is something that we wouldn't say that, but they are less knowledgeable given, and it really would be given the quality of information we get from television. And anybody who studies media will tell you that at least U.S., and I can't speak for the rest of the world, but U.S. television news, surface level, focused on who's winning, who's not winning, where are the candidates today, not the sort of in-depth understanding that the questions are assessing. And then we can do the same thing for advanced degree, and we get also negative slope. Easy enough. So I'm not going to ask you to do this just for your edification. I'm not going to ask you to do this for the take-home exam. But there might be some general questions on the in-class exam, or there might be some more general questions on the take-home exam about distinctions between mediation and moderation, and maybe helping outline some steps that one would take. But I'm not going to say, here's some data, do this. But that doesn't mean that there won't be. There definitely will be questions, but the questions will be, you won't have to carry this out, but it's not terribly. If you sort of followed it from the start and worked through the steps, you would, I think, easily be able to get to this point. The next point would be just to take these equations, right? And we remember from 6th grade math or whenever when we worked with two-dimensional plane, if we have this equation, we give a couple values for x, we can put 2 points on the plane, and we can draw straight lines between those 2 points, right? And so that's what I did here. And I just used the min and the max for x. You could use 2 other values. Wouldn't have to be the min and the max. I just happened to do. That's just what I did. And so if we plug minus 10 and minus 18 into these 3 equations for high school, BA, and advanced degree, you're going to get these values, okay? And then with those values, you could use any number of tools, but this is SPSS. I just put a table that looked just like this into SPSS. Although you can't define your rows as min and max, so it's just as row 1, row 2, and this is high school, this is BA, this is advanced degree, and so I just had to change this to minimum TV, maximum TV, and it gave me the lines for high school, BA, and advanced degree. So squares with the equations that we looked at earlier, where somebody with only a high school degree, who the more television they watch, they tend to learn more about, or they tend to know more and or learn more about politics or some current campaign. But the same isn't true for people with a bachelor's degree and advanced degree. The slope of the line, of course, is steeper here for advanced degree than it is for a bachelor's degree. And maybe, there could be a number of reasons for that. But it's not, it's a bit counterintuitive. One would think the more media that you consume, the more you should know about. But in this case, it really is the nature of television news. Newspaper would be, all 3 of the lines would be sloped in a positive direction. Because newspaper doesn't have the same, and there wouldn't be an interaction either. The 3 lines would be sloped at about the same angle. Although the advanced degree, people who have advanced degrees tend to know more about politics, and people who have 4-year degrees tend to know more about politics. than people who have high school education. So, questions? So in this case, what we're saying is that television, the relationship between television news and issue knowledge is moderated by levels of education. The level of education matters in terms of this relationship, right? And we can see how that matters graphically in front of you. Okay? Questions? None? So we're going to talk about mediating variables next week. We will not be here for the entire class period talking about mediating variables. But what you might want to think about doing is, if you have a few minutes to put together your thoughts about questions you would have for the exam or questions you have for me about the exam, I will be happy to take the time after we're done next Monday, and we can spend the rest of the class period or however much or little time you want to spend doing that. We can do that. Starting,
In terms of studying, should we just go like by the syllabus, like go through the sections that are going to be on the test, or?
yeah, and I think the if there's a good thing about the take-home part of the exam, is it's going to refresh your memory about. So I think carefully working through and doing more than maybe just getting the details of what you need to answer a particular question for the take-home part of the exam would be the way I would recommend preparing for the class.
Explaining why.
Yeah, or thinking of not just answering a question that I have for you, but there might be, that's all I want you to do for the exam, but as part of the process of doing the exam, you might want to sort of broaden your work a little bit because it would prepare you pretty well, I think. There's a lot of similarities between the syllabus, the take-home exam, and the in-class exam. The topics emphasized here will be the topics emphasized there. Good. Other questions? See you next Monday, if not before.